purpose of this video is to review rate. Rate is something we've seen in our earlier studies, so let's do a review. In the previous video you may have seen an example of a ratio. We talked about an example of a ratio, 1:25, and that was an example of two-stroke fuel where we had 1 part oil and 25 parts petrol to create two-stroke fuel. So if I was mixing some two-stroke fuel for my fuel tin, and the fuel tin was 5 litres or 5,000 millilitres, I would need to work out how much of the oil goes with that. We use the ratio, that would be 200 millilitres, and that would simplify dividing through by 100 as we did in the previous video. 2:50, we've divided both sides by 100, 1:25. But notice how the ratio is a comparison of things with the same or similar units. They're a comparison of things of the same or similar quantity, or type of quantity. Today we're looking at rate, which is a comparison of quantities. These quantities have different units or unlike units, so they're related. Just like with ratio, they were related, but the quantities are not alike, measuring quantities of a different nature. So that makes a rate, which means the units will be different. So that's an important point to note. Some examples of rates. There are many examples we see each day. For example, if we look at the picture here, this gauge you can see to the left there is called a tachometer. Tachometer, and it measures engine revolutions per minute, revs per minute. This one here has a second gauge inside. If you can see the green window, it has a fuel economy gauge or a fuel consumption gauge. Now that one has MPG next to it, and albeit that's their old imperial measurements, but it's still used a lot each day. That's miles per gallon. There are metric versions of that. Miles per gallon, kilometers per liters, or liters per 100 kilometers is the metric equivalents. Are the metric equivalents. They're both rates, because you can see that the quantities are related, but they're different. This one's revolutions, how many times the engine goes around in full circle per minute, which is a unit of time. The fuel consumption is miles, which is distance, per gallon, which is a capacity or a volume. Another example is speed or velocity. If we go 50 kilometers per every 1 hour we travel, we know that as 50 kilometers per hour. And we know that our symbols can be abbreviated 50 kilometers per hour. That's a speed, and that's a rate. When we go to the shops, if we buy $10 worth of bananas, and that gave us 2 kilograms, we would call that $5 per 1 kilogram, and we would see the price advertised at the supermarket as $5 per kilo, written like this. If we were filling up a vehicle with a large fuel tank, like a fuller drive, it might cost us $150 per 100 litres of fuel. which would mean we would spend $1.50 per each litre. And if we looked at the price advertised on the pump or the sign at the fuel station, it would be 150 cents per litre, C/L. That's the convention for fuel prices, cents per litre. They're all examples of rates. They're everywhere. Looking at some specific mathematical examples. So if we have to write the following as a rate, if an engine turns 10,000 times, or it goes through 10,000 revolutions, revs for short, in 2.5 minutes, write that as a simplified rate. The word per means the operation in maths divide. So to write as a simplified rate, we go 10,000 divided by 2.5 minutes, or 2.5. This will give us 4,000 revs per minute. 4,000 revs per minute, or RPM, they're called in everyday talk. So the idea is to get the bottom, the denominator, as 1. So that would be the same as 4,000, because that's the same as 4,000 over 1. 4,000 over 1 is the same as that 10,000 over 2.5. The idea is to get the second quantity down to a value of 1, if possible. And so that's why we divide by 2.5. So 4,000 revolutions per 1 minute. We say 4,000 RPM. That is a simplified ratio. Second and final example. If we have a car travelling at 90 kilometers per hour, car is travelling at 90 kilometers per hour. That's a speed. A speed is an example of a rate. If we analyse that, the speed is made up of a distance related to an amount of time. So speed is distance per time. Distance per time. Remember, per means divide. So in fact, that is why the formula for speed is distance over time, because it's a distance per time. Distance per time. If we had to do two things regarding this rate, part A is the first one. How far will it travel in 2.5 hours? We look at our speed, 90 kilometers every 1 hour. In 2 hours, there are 2.5 lots, or 2.5 groups of that 90 kilometers. So it's a case of groups of, meaning multiplication. So to get the distance, we go distance is speed multiplied by time, because it's groups of, which would be 90 multiplied by 2.5. Which is 90, 180, 180 and 45 is 225 kilometers. The second one, how long will it take to travel 360 kilometers? Well, again, speed is distance per time. We want to know how we get time. How long? Well, let's have a look. We have 90 equals 360 divided by something. We don't know what that something is. We could do a bit of guess and check, but perhaps there's a more efficient way than guess and check. when we have the unknown on the bottom, one of the ways of working is to turn both sides into fractions. 90 is 90 over 1. 360 over the missing value t. So a couple of ways of doing this. One of the ways is to use cross multiplication, and the other way is to invert both of the fractions. I'm going to show the cross multiplication way in this video. If we diagonally multiply to get rid of the fractions, that would give us on the left side 360 times 1, and on the right hand side 90 times t. So 360 equals 90t. Divide both sides by 90 to find t, and t would equal 4 hours because it's kilometers per hour.